Hello, Calc students. I'm going to do a quick video here on the intermediate value theorem. So, reminder of the statement. So this is one way on my let's see, on my left, the way you see it, to remind you of the intermediate value theorem, which we'll often abbreviate IVT. IVT is a big if-then statement. The if part is you need a function f that is continuous on a closed interval from a to b. Then you have some number y equals m, and m is strictly between f of a and f of b. It cannot equal f of a or f of b, and f of a and f of b cannot be equal to each other because m needs to be between two different numbers. Then, so if the first two bullet points on top are satisfied, then IVT allows you to conclude the following. Then the intermediate value theorem guarantees the last bullet point. At least there is at least one x equal to c in the open interval a to b where f of c equals m. In a lot of problems, m will be 0 because what you're searching for are zeros of a function or solutions to an equation or an x-intercept. Sometimes the m will be some value that's not 0, so you got to find where the function is crossing that value. Okay. Really quick example. Here we go. And I'm going to show it I'm going to use this. You may have seen this in the homework, or it might have been slightly different. I went from memory. But anyway, this is the one I want to do. Okay. Now, prove that there exists a number that is 1 less than its cube. Well, first, let's write an equation that relates this. So let's let x be the number. And we want x. So is x equal to its cube? No. X is 1 less than the cube. So that means x is less than this. So we would be subtracting 1 from this side. So this is saying take x cubed minus 1 and set it equal to x. If I can find a number that makes this equation true, then I have found a number that is 1 less than its cube. Notice the problem says prove that there exists a number, that there is a number that does this. Whenever you see a question that says, is there a number in an interval that satisfies blah, 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 that is saying prove that there is one. It doesn't say find one. It doesn't say actually solve it. Okay, couple ways you can do this one. One way is to move everything to one side. So I can have 0 equals x cubed minus x minus 1. So I just subtracted x from both sides and I wrote it this way. Now I can let this be my function. I want to show that there's some place where this function equals 0. That's equivalent to showing that this function has a 0 or an x-intercept. Well, first, if I'm going to use IVT to do that, I need to make an argument as to why this is continuous. So you state that in this case, f is continuous because it is a polynomial. Little terminology thing. If you ever say f is continuous, it's going to be assumed that f is continuous on its entire domain. And in this case, it's continuous for all real numbers. So f is continuous, and if I want to be really specific, f is continuous for all real numbers. I'll just say for all reals. Thus, f is continuous on any closed interval, a to b. Pick any closed interval you want. You don't literally need to state this. I'm being very careful to show you the logic of the argument. If you need to establish that f is continuous, and if it was a problem where you were given a specific interval, like an interval from 0 to 5, then you would need to state that since it's continuous for all real numbers, then the function is continuous on the closed interval we're actually analyzing. Okay, so now next, I need to find an input value that gives me a negative number and an input value that gives me a positive number. Then there has to be a place where the function equals 0 in between. Now you could play around with this. I'm just going to do this. Let's just do f of 0. Isn't f of 0 clearly -1? And what is f of 1? F of 1 is 1 cubed minus 1 minus 1. So isn't that, so 1 cubed is 1 minus 1 minus 1. That's -1. So that's still negative. What is f of 2? F of 2 is 2 cubed minus, 2 cubed minus what? 2 minus 1. So that is, let's see, 8 minus 2 is 6 minus 1 is 5. Okay, cool. Now, what we've just found is that f of 1 is -1. F of 2 is 5. Since this is less than 0 and this is greater than 0, we've found our interval. So here's what we can say. Since f of 1 is less than 0, is less than f of 2, then IVT gives us, or guarantees, there is an x equal to c in the interval from 1 to 2. Now that's an open interval. It doesn't include the endpoints. There's an x equals c in that interval such that f of c equals 0. That does it. We're done. Because now what's the logic? There's a c inside of this interval where f of c equals 0. Well, that would be a c that I could put in here, and this would be 0. But that would be a c that solves this prior equation. Okay? And that would be a c that solves this prior equation, and that would be the c that is 1 less than its cube.